Okay, so here's the third and final part of the video review for the 6.1 to 6.3 quiz. And we really have these last questions to go, 20 to 25. Now, 20 to 23 are really, really easy if you recognize them. So we're going to work on recognizing them. Uh, Exponential functions and logarithmic functions are inverses. So when you combine them, they'll cancel each other out. So if you look at the first one, 2 to the log base 2. Well, the base of the exponent is 2 and the base of the log is 2, which means they are inverses. Those will cancel each other out, and you're left with 2x minus 6. That's as simple as it gets. This one, e is the base of the exponent. Natural log, remember, has a base of e. You just don't see it. That's not how it's written, but it does have a base of e. So since they have the same bases, e and natural log, e to the natural log, they will also cancel each other out. So you're left with 10x, and that's it. Now, when you're taking the natural log of an exponent like this, same thing happens. You're combining them, you're just combining them in a different direction. Natural log has a base of e, you just don't see it, like we just said. And you're taking the natural log base c of an exponent that already has base c, so those will cancel each other out. This is key when we're going to be solving these equations, so it does become a little bit more important later. But anyhow, I digress here. This is log base 33 of this exponent that has base 33. So it doesn't matter what this is up here, the log base 33 with the exponent 33 or the base of the exponent cancel each other out. So you're just left with this. So those are easy. That's the answer. There's the problem. Now, these problems are a little bit more complicated, but they're not too bad. To find the inverse of any function, that's what we're looking for. Start with an x, and then undo everything in this reverse order of operations. Parentheses, exponents, please excuse, multiplication, division, addition, subtraction. Now, exponential, this exponent, that also includes logs. You never learned about logs before when you learned that, please excuse my dear Aunt Sally. Now you know them. They're in with the exponents. So when you look at this problem, the first thing you should see is you have an exponent, log base 4. You have these parentheses. Those are the last two things you'll take care of. The first thing is this multiplication. You're multiplying 11. So you have to undo the multiplication. So we're at this step right here. There was none of this. So undoing multiplication is division. So to get rid of the 11, divide by it. Gone. Now you have to get rid of the exponent or the log. Well, it's log base 4, so its inverse to get rid of it is the exponent with base 4, or 4 to a power. So you just take that base 4 and you change it to an exponent as part of the inverse. So this x over 11 is now the exponent of the 4, because that's the inverse of log base 4, and we just got rid of that. And finally, you have x plus 12, which was in the parentheses. You undo that by subtracting the 12. So that doesn't look very nice. Let me just clean it up. It's 4 to the x over 11 minus 12. So just undo everything in the correct order, knowing that exponential functions undo the logs and logs undo exponentials, just like we're going to see on this next problem. 25. We're still trying to find the inverse. So let's start with an x. I'm going to put it over here because I know I'm probably going to have to do a log. So I'm going to leave room for it. So we have an exponent right here. We have this division right here. And this plus 19 is up with the numerator. So you can't really consider that an addition before you get rid of this division, if that makes sense. So if you were to solve this, the first thing you'd have to do is multiply by 3. So we're going to multiply by the 3 to get rid of that because it's divided by 3. Now we have 18x plus 19. The plus 19 is not part of the exponent, so we can freely get rid of that by subtracting it. Finally, what we're going to do is get rid of the 18. It's a base of an exponent. It's base 18. So the inverse of the exponent base 18 is the log base 18. But it's very important when you're doing these inverse that you don't just put the log there. You want to do the log to the entire side. So always, and this goes with any inverse that you do. Each time you do something, you're doing it to the entire side. So you're going to have to show that with parentheses. So that is it. That was the entire review. Make sure you got it. Go back and practice. And if you need to look at this again, well, you get unlimited views. That's the beauty of it. So have fun.